Hi guys, STAADPro again with a new video. In this video, what I will discuss is the design of a steel beam, which is very similar to the previous examples. In last two videos, what I discussed was design of a steel beam with number one, continuously braced upper flange, and the second was braced at middle thirds. Now the same beam, same loading, same span, we are going to analyze for the support at the midpoint. Now here you can see that we are going to discuss W-shape flexural member design in strong axis bending braced at mid span. Same problem, this is W18 by 50, the span is 35 feet and it is braced at the central point. Now from our previous calculation we know that the applied load or applied bending moment was 184 feet. Now unbraced length is half of the span, that means 17.5 feet. Now for a uniformly loaded beam braced at the ends and at the central point, CB is 1.30. This is from manual table 3.1. So let us see what conditions are given in manual table 3.1. So here is the table 3-1, the value of CB for simply supported beams. On the left hand side we can see there are loads, and the middle the bracing, and at the end we can see the value of CB. So initially these loads are point loads, but for our case we are looking for UDLs. So in case of a UDL and it is supported at the midpoint, the value of CB for both the span is 1.30. That means the value of CB should be used as 1.30, correct? Now there are several ways to make adjustment to table 310 to account for CB greater than 1. Now we can check what values are given in table 310. There is one procedure given over here. Rather, they discuss two procedures, procedure A and B, but we will discuss procedure A. This is that the available moments from the sloped and curved portion of the plots from table 3-10 may be multiplied by CB, but may not exceed the value of the horizontal portion, that is 5 times Mn for LRFD case and Mn over omega for allowable stress design. So we are interested in Mn, or the nominal moment divided by omega. Now to obtain the available strength for W18 by 50 with an unbraced length of 17.5 feet from the manual, we have to go to table 3-10. When we go to table 3-10, this is table 3-10, and we can see that W18 by 50, this is the curve for W18 by 50. This W18 by 50 does not go to a span length of 17.5. So what we can do, we can extrapolate the values. What I did here, I took the values for span 8 feet and span 10 feet and extrapolated. Here I can show you. These are the values for 8 feet and 10 feet. I can see the 8 feet, the value of moment is 234, and for 10 feet it is 216. For 17.5 feet, my extrapolated result is 148.5 feet. When I checked with this value over here, it is quoted approximately 147 feet. Fair enough. And then it is multiplied by CB, and then the nominal resistance comes out to be 191 feet, which is of course larger than 194 feet. So that means this beam is safe for under this condition also. Let us see what STAAD can do. So going back to the same data file, now I can change the unsupported length for the top flange. Instead of 128 inch, now it will be 210 inch. And value of CB will be 1.30. In fact, I am more interested over here. I have to revise 210, which is equivalent to 17.5 feet, and I have to revise here 1.30, modify, change. Let us save and analyze. Analysis done. No error, no warning, no notes. Let us go to, stay in the modeling mode. Let us select by specification all failed beams, no beam fails. That means this beam qualifies even under this condition. Let's see the output, and here I can see that the value, the ratio, the stress ratio is 0.93. So if I divide 184 by 0.93, it comes out to be something around 197 or 198 feet. So that means the STAAD properly design a beam, but there is a catch. Most of the engineers, in my experience, what I saw, although they use this command UNT, but they forget to modify the value of CB. And if we do not modify the value of CB, this beam is going to fail. Let me show you. If I change it to 1, which is the default value, so if I forgot to change this value of CB and let it be the default value, what will be the result? Done. Let's see. All failed beams, the beam fails. Here is the mistake, and I should warn all the engineers that if you are designing a beam with a STAAD, a steel beam especially, you should pay attention to define the unsupported length properly and corresponding CB values. Don't leave CB values for the default, which is 1, and the result will be a beam will be failing. And to meet this requirement, what you will do, you will increase the size. So unnecessary, you are going to put a heavier beam than required. Let's see the result. So here is 1.07. That means I have to change this beam. That means a W18 over 50, maybe it will be a higher beam. So it will be an uneconomical design. So please do not this mistake, and always define UNT and CB both. So this is a big lesson learned. Thank you very much. If you think that this is a helpful video, please give me a like, and please do not forget to subscribe me. Thank you very much.